Hello, hi everyone, and welcome to the Supercharging Your Data Science Project with GitHub Tools session of the Python Data Science Day. While celebrating Pi Day, we are going to explore some tools within the GitHub platform that can help us enhance our data science workflows. But before moving on with our topic today, let me quickly introduce myself. I'm Carlotta Castelluccio. I'm a cloud advocate in Microsoft. I'm focused on machine learning and artificial intelligence technologies, and I'm based in Italy. My job's mission is to help every student, developer, or entrepreneur succeed with AI by building innovative solutions responsibly. And to achieve this goal, I develop technical content and host skilling sessions like this one, hopefully enabling my audience to take the most out of AI technologies. Now, AI technology is advancing at a rapid pace, bringing new innovations that are transforming our workplace. And one role that is being especially disrupted by these advancements is that of the data scientist. So the role of whom is building those AI models. Data science is already an exciting field, but new tools are taking it to the next level in terms of productivity and capabilities. With the help of these new technologies, data scientists can work faster and more efficiently than ever before. And in this session, I show you these advancements in action. To explore those innovations in tooling, let's imagine we have been asked to create a predictive model to forecast the number of rentals for a bicycle rental business based on seasonality and weather conditions. And to build such a model, starting from an historical rentals dataset, we're going to perform some data analysis and experiments in a Python Jupyter notebook on Visual Studio Code. And the secret sauce of the productivity boost to our project is made by two main ingredients, GitHub Copilot and GitHub Codespaces. As you all know, GitHub was born as a web-based platform based on Git and used for version control and collaboration on software development projects. But year by year, the platform has evolved a lot, becoming much more than that. And tools like Copilot are so key within the platform that GitHub CEO recently stated that just as GitHub was founded on Git, today the org is refounded on GitHub Copilot. Copilot is an AI-empowered assistant embedded into the Visual Studio Code interface, but available also in other text editors and IDEs, and offering inline suggestion as you code in different languages, but also /comments to accelerate repetitive tasks and the chat experience. It's based on an OpenAI large language model trained on data extracted by a high volume of public GitHub repository, and it's the most widely AI developer tool used today. On the other hand, GitHub Codespaces is a predefined development environment hosted in the cloud, coming together with a seamless attached text editor, which by default is Visual Studio Code, accessible via web browser. So you can even run your code through a mobile phone if you can connect on the internet. By default, Codespaces are created from an Ubuntu Linux image that includes a selection of popular languages and tools, but you can customize your project and configuration for all your users of your project. So this basically creates a repeatable Codespace configuration for all the users. Let's see those things in practice by jumping into Visual Studio Code. So first thing first, when we open Visual Studio Code, we have an empty workspace. I believe that starting a new project and setting up everything we need to work on it is probably the hardest part. An empty workspace might be intimidating. Once you get started, going ahead becomes more smooth. Now, before we can start writing our first line of Python code, or even start creating a new Jupyter notebook, we need to have the last version of Python installed on our local machine, and the Python and Jupyter extensions installed in Visual Studio Code. And that's not all. Then we also have to install the Python libraries needed to explore, to clean, to visualize the data, and the ones needed to train and evaluate our machine learning model. So lots and lots of installation prerequisites, dependencies. Now, this set of prerequisites may vary from one project to another, and some of them might have conflicts and dependencies requiring some additional efforts to our data science workflow. Also, if we collaborate with a team of colleagues on the same project, they should replicate the same installation processing on their machines to be able to contribute to our code. But hey, don't worry, we are in 2024, we have artificial intelligence, we have GitHub Copilot, we have GitHub Codespaces. So let's see how we can leverage those tools. Once we have enabled GitHub Copilot chat in Visual Studio Code, we can interact with this built-in virtual assistant through a chat interface by asking questions in natural language or using chat agents. So from the sidebar menu, let's open the Chat tab and let's work with agents. We can think of an agent as an expert we can ask for support on a specific subject. Similarly to when we mention a user in the chat, we can use the @ symbol to start interacting with an agent. And then, to further define the scope of our request to the agent, we can also use a few / commands. Let's do an example. So to create our workspace, we can use the agent @workspace, and then we can use the / command /new to specify that we want to create a new workspace. And then we can add some further description of how we want this workspace to be created. So we can add the description: a new workspace for a Jupyter Python notebook with the GitHub Codespaces configuration, installing Pandas, NumPy, and scikit-learn, which are some common libraries for doing data visualization, data analysis, and machine learning tasks in Python. So by sending this message to our workspace agent, we will get a suggested directory structure for our workspace project, including several files. First of all, the devcontainer.json file into the .devcontainer folder, which is a configuration file for the GitHub Codespaces development container. If we open it, we will see that in this file, we'll have, for example, the specification for the Docker image to use, and the extensions to install in the dev container. Then we have a Docker file placeholder where we can add a Docker file containing additional instructions needed to create the Docker container image. We have a requirements.txt file listing the Python packages to install in the development container that we will use in our project, like Pandas, NumPy, scikit-learn, and Jupyter Lab. And then we have a notebook template, which is a template Jupyter notebook file, importing the requirements listed into the requirement.txt file, and with some other things. So basically, we have here one single cell, which is a starting point, of course, for our notebook. It's not a complete notebook, but still, it's a good starting point, right? And then we also have a README file, which is a placeholder file containing the documentation for the project. Now, by clicking on the Create Workspace at the bottom, the directory structure will be created locally, and the files will be initialized with some basic content that we can customize for our scenario. Basically, we get a project skeleton that we can use to kick off our project. Much better than starting from a blank space or an empty workspace, right? But now, let me jump to my demo project workspace, where I've already added some customizations to these template files created by GitHub Copilot that will allow me to show you some other cool stuffs. So in my example of the data science project, we want to build to forecast the bicycle rentals trend. To complete my container setup, I added my Docker file in the Docker file folder with the definition to my dev container image. Then I also customized the list of extensions in the devcontainer.json by adding the Copilot chat and the GitHub Copilot Visual Studio Code extension. In a way, these are installed when launching a new Codespaces remotely, because I want them to be there to support me in my data science workflow. And then I also added some further requirements to my requirements.txt file that I know I will need throughout my project. Of course, I also added my Python code to the Jupyter notebook template. But before going into the details of the notebook, let me create a GitHub Codespaces to execute it based on the configuration files we just explored. Now, to create a GitHub Codespaces, you need first of all a GitHub repo, remote GitHub repo. So you need to create a repo hosting your code remotely. You can do that directly on the github.com website, or you can use the Visual Studio Code built-in features. Now, clicking on the source control button here, you see that my code is already linked to a remote repo. But if you are not connected to any remote source, you'll find a button here to initialize your repository with a graphical user interface. Once we have our code hosted in a remote repository, we can ask again support to GitHub Copilot chat to create a remote GitHub Codespaces on top of our repository by opening again the chat window and using this time another agent which is called Visual Studio Code and which is specialized on questions about Visual Studio Code facilities. And then we can specify our question to the agent, which in this case will be, how can I create a GitHub Codespaces on top of this repository using Visual Studio Code? This time, our expert agent will return a list of instructions to achieve our goal. So you see, we have, first of all, open the command palette, then type the create new codespace command, and so on and so forth. So let's follow the instructions using the suggested keyboard shortcut. So opening the command palette from Ctrl-Shift-P, and then clicking on the Codespaces create new codespaces command. And we will get a list of repositories from the GitHub account connected with Visual Studio Code. So my GitHub account in this case. You can see that here I can basically pick the GitHub repository on top of which I want to create my new Codespaces. So once I select the repository, the creation process starts, and we should wait a few minutes for the Codespace to be created properly and open it within Visual Studio Code. But for the purpose of this demo, to speed things up, I already created a GitHub Codespace beforehand. So let's just check that we are connected to it from the Remote Explorer tab from the sidebar menu. Here you can see all the specification, the details, the status of the connected workspace. Now that we are connected to our GitHub Codespace, we can have a look to our Jupyter notebook and execute it in our remote environment. what we can observe is that the kernel defined in the configuration file has been loaded successfully with the creation of the code space. And since this customized kernel is pre-configured with all the dependencies we need, all the packages imported in the notebook can be used without the need of any further installation. Let's look at the code now. This is a very simple Python notebook with a few code chunks. The first code cell imports the dataset of the history of bicycle rentals from a URL into a pandas data frame. This is the data we'll be using throughout the data science workflow. And then the other code cells perform data visualization to explore the distribution of the data with a few graphs. And then we have the training and testing of a linear regression model to predict the future sales trend of the bicycle rentals. And finally, we have the evaluation of the trained model using mean squared errors and other evaluation metrics. Let's now add a new code chunk to visualize the difference between the actual and the predicted values with a scatter plot, in which we have the actual values of daily bike shares on the x-axis and the predicted values on the y-axis. So if I start type PLT, which stands for plot, and then dot, you can see that GitHub Copilot starts suggesting me the completion of the code in line. So by going over the gray text, which is the GitHub Copilot suggestion, I can choose between accepting all the suggestion, accepting a portion of it, or just ignore it and continue with writing my own code. So in this case, since it's exactly what I want to write, I will going to accept the suggestion. So defining my scatter plot with the y test and the predictions values. And then you see that as I continue, GitHub Copilot continue to provide me with suggesting the completion of the code. So defining the X label, Y label, the title, and so on and so forth. So if now I complete my code cell and then I execute it, I get the desired graph. Note that GitHub Copilot is able to provide me with relevant suggestions here because the large language model on which it's based is augmented with my projects file. I have it opened in my workspace. But let me show you another thing. Let's imagine that by writing our code, we made a mistake. For example, by inserting a typo in the name of the y-test array. Now, by executing this code cell now, I would get a name error exception, since there's no defined arrays matching that name, right? In a case like that, GitHub Copilot can assist us troubleshooting the error. We just need to click on the Fix Using Copilot button, and we'll get an analysis of the error, along with the suggested code changes to fix it. In a layout very similar to the one of GitHub changes, GitHub edits. So a kind of layout I'm quite familiar with as a GitHub user. And the same can be accomplished by using the /fix command in the inline chat that you can open using the Ctrl-I keyboard shortcut. So you have the choice of using the button or opening the inline chat and use the /fix command with additional specifications if needed. Now, once our code is fixed, there's another challenge we might need to face: documentation. Drafting clear documentation for our code is essential to make it readable when shared to collaborators, customers, and even for our future selves. It's hard to recall every single piece of the code we write without documentation, right? Again, we can accelerate this tedious and time-consuming process through GitHub Copilot. By selecting the piece of code of interest, we can then use a / command in the chat window to generate the relevant documentation. The / command we are using this time is the /doc command that helps us easily get the detailed description of our piece of code, line by line, that we can use, for example, as the content of a markdown cell in our notebook, since Jupyter Notebook allows us to alternate code to markdown. So we can copy and paste it in a markdown cell. Here it is. And of course, we can review it and edit it, but for the purpose of this demo, we will just accept the output as it is. Finally, by saving, my changes will be saved in Codespaces, but not on the remote repository. This means that if I accidentally delete the Codespaces or if it expires, I'm going to lose my edits. So I need to push my commits, and to do that, I can use again a built-in Visual Studio Code functionality provided by the source control panel. And there's another painful moment, right? When you need to add a description to your pull request. But you know what? You can now ask to GitHub Copilot to generate for you a relevant message for your pull request. And you are all set with, just one click. Here I had already a suggestion, but if I click again on the button here, I have this field populated with a new suggestion describing exactly the changes I've applied to my project. That's it for our demo today. Let's now jump back to our deck to do the session wrap-up. In this session, we provided some tips and tricks for data scientists to improve their productivity and enhance collaboration by leveraging GitHub tools, Python and Visual Studio Code. We covered how to create a reproducible workspace using GitHub Codespaces and interacting with GitHub Copilot through a chat interface to streamline project setups. We also demonstrated how GitHub Copilot provides inline suggestions, assists with debugging, and helps automate documentation tasks, ultimately improving the efficiency and effectiveness of data science workloads. Keep learning using the links provided in this deck. You can replicate the demo on your own, since the code I used is available in a public repo at the link you see on the screen. And if you're going to try the prompts we used in the demo in your environment, be aware that you might get different results, since the Copilot engine is a non-deterministic large language model. So for the same input, you can get different outputs. And if you'd like to share your learning journey with AI enthusiasts like you, join the AI community Discord server at the link on the screen and stay up to date. Thanks for joining, and happy Python Data Science Day. Bye-bye.